And so when you're looking for, anytime you see maximum revenue in this case, but if you're looking for a maximum, you're looking for the vertex of a parabola. Okay, so it's going to be a quadratic function. So when we look at this, we're still looking at a revenue here. And then the revenue is the price times the number of items sold. Okay? And so when you're looking at this particular case, oops. Let me eliminate these because these are not dollar signs here. All right, so when you're looking at the revenue, you're looking at the price that is being paid and then the number of items being sold. Okay, so if you start with the initial price and cost, okay, or the price and the number of items being sold at the beginning, that tells you basically what the revenue you're building from. So when the cost is $12, the sales are $27,000. And so that's where you're going to start your equations here. Your equation is going to be two parts. The first part is the adjustment to the price. And the adjustment to the price has to do with the increments of that change. Okay? And so when we look at the function of this, we're looking at revenue as a function of x, where x is some number of increments of some specific cost change. So when we go from $12 to $10, what is the change in our cost? It's $2, right? So it's a minus $2. And what we want to do is we want to see that if this is in increments of x. So it's what number of $2 decrease increments is going to give us this maximum value. So that's how we would represent that first part of the equation. And then the second part, we're going to see for every x increments of minus $2, there's an increase in the number of people that show up by what? It's not 34,000, right? So this is a $7,000 or 7,000 person change, right? So it's 7,000 per increment of x. You get that same increment in the attendance increase. Does everybody see where those numbers come from? They weren't specifically given in the problem, but they were indirectly related to the numbers in the problem.
I'm a little confused. Where did the 2 come from?
So the 2 is the difference in the price. So the price went from 12 to 10, so that was the minus 2.
And x is the price that goes.
So x is the number of times that increment of change happens in this case, that's just a 1, right? It's just one time. But we want to find for every time that it decreases by $2, the crowd goes up by 7,000. And so this is the sales change, right, or the difference in sales. So notice the signs. Okay? Sales went up when the price went down. Okay? If this was written where the price went up, more than likely the sales would go down, and you'd still be able to solve it the same way. Okay? So questions on deriving this equation first. Once you have this equation, in order to find the maximum revenue, you have to locate the x-coordinate of the vertex for the graph of this function. Okay? And so what we can do, the easiest thing to do here would be to expand this. Okay? So if we take this function right here and we expand it on our calculator, it's going to give us the general form of the quadratic that relates this information. So I'm going to go to expand, type in my factors, 12 minus 2x times 27,000, plus 7,000x. And I'm going to close that off. And when I do, I now have my function. So this right here is my function. I don't need to write it down because I'm just using 2 pieces of it. I'm using the b and the a because I'm going to use my vertex. The x-coordinate of my vertex is negative b over 2a. Okay, so if I look at what I have here, my calculation of the vertex, I get my b value was again the 30,000. And I'm going to divide by 2 times my a value, which according to this was negative 14,000. Right? And so when I do this calculation again, my factors of 0, or the tens, thousands here, cancel. My sign cancels. And so I wind up with 30 over 28. And so when I calculate that, and I'll put it in decimal form, okay, I get 1.07. Okay, so there's 1.07. What does that number actually represent? It's the number of times a decrease of $2 happens to get your maximum, the maximum revenue. So what I'm going to do is I'm going to take this number that I found right here, and I'm going to substitute it into this portion, just this factor right here, and I'm going to evaluate that at this 1.07 approximately, but I'm going to use the exact numbers. But I get 12 minus 2 times this number. And this is the cost of this is what the price should be for that car wash. So $9.86, we round it up. It's a dollar amount, so we round it to the nearest penny. So 9.86. And that would be the optimum price for a car wash in order to maximize the revenue. All right, questions on the process that was used there? Okay, create your equation, expand it, convert and solve for the x-coordinate of the vertex. Okay, and then once you have that x value, plug it back into this cost part, or this first part of your function, and that will give you your optimum price.